implementing and maintaining indexes. So I'm sure we've all owned a technical book or two, especially those consultant books or those the administrator's companion kind of books, where they're just books that contain lots of tips and tricks on how to do specific things, usually common tasks. Same in the SQL world, those cookbooks that contain lots of recipes for doing certain things in Transact SQL. Yeah, well, imagine having to find something in those books by going page by page. It would take forever, right? Well, that's where indexes come into play. Indexes in books are just like indexes in SQL Server. They give us a very fast way to find what we're looking for. In the SQL world, uh, they're one of the greatest things we can do in a database for performance because we're giving SQL Server the ability to do the exact same thing, to look in the back of the database to find out exactly what they're looking for and jump right to it rather than scanning all of the data pages to find what it's looking for. So indexes are great, they're awesome, and they're usually one of the first things that DBAs and developers should look for when it comes time to increase the performance in a database because it's a cheap solution. We don't have to add hardware or look at other alternatives. It's right there built into the database and it gives us a way to increase performance. So we're going to take a big nugget here on indexes, all the cool things we can do with them, and you'll get some good insight on how to use them because really the most important thing when it comes to indexes is knowing what to index. Because sure, you can just put an index on something and say, hey, that should solve the problem. But if your queries never use that index, then what's the point of the index other than the overhead that it's going to create for maintaining it? So that's why it's good here to start with an overview and get familiar with how indexes are structured under the hood. So we'll get familiar with what B trees are, what they do for SQL Server. We'll talk about heaps. We'll talk about non-clustered, clustered indexes, and just get familiar with general basic indexing terminology and concepts. Then we'll move into another slide and talk about all the different index types. We'll talk about clustered indexes, non-clustered indexes, covering, filtered. We'll even touch on XML. We'll talk about the new column store index and some other ones as well there. And we'll talk about some design principles, things like statistics and how they affect indexes, and the query optimizer and how it uses statistics to find what's known as an execution plan or a query plan and put it to use. We'll even take some general guidelines here when it comes to developing indexes. From there, we'll jump over to the Virtual Nugget Lab and learn how to create indexes. We'll take a look at all the index types. We learn about how to create them, and more importantly, we'll look at really how to design an index appropriately. And what I mean by that is based on the queries that are hitting our database, we should be designing and creating these indexes that these queries are going to use. And I can tell you in the databases I've seen that just have random indexes that are never used. And that's really bad because now you're actually hurting performance. Because anytime an update or an insert or a data modification hits that table, that index that isn't being used, SQL Server has to waste resources on to manage. We'll also take a look at how to work with indexes, and we'll take that concept of unused indexes, and I'll show you how you can discover them. We got some great tools here in SQL Server reports and DMVs that we can use to find out what indexes are rarely used, if ever used, and then delete or disable them so we can save SQL Server on some maintenance costs. And at the very end here, we'll take a look at how to maintain indexes. Specifically, we'll learn how to deal with fragmentation. We'll talk about rebuilding indexes versus reorganizing indexes. And at the very end, I'll take you through how to create a maintenance plan to manage your index strategy. So to get a good handle on how indexes work and how they improve query performance and how they can retrieve data so fast, it's good to understand how they're structured and how everything in SQL Server is structured, and by everything I mean tables, without an index. So without an index, if you create a table, you put no index on it, you're going to have underneath that table just a bunch of data pages in what's known as a heap, a big steaming pile of data that's all held together through what's called the IAM, the Index Allocation Map. So that's really it. And if the more data that comes in, it just keeps getting piled on. And when it gets inserted, there's no logical or physical ordering of anything inside of here. It's just simply one big pile of data. So what that means is when a query is executed against this table, SQL Server has to scan the entire heap to find what it's looking for. So let's add an index to our table here. Our basic table that's nothing but a big steaming pile of data right now. It's a big heap. And if we add an index to this heap, what we'll do is we'll specify a key. All indexes are based on a column, one or more columns, and those are going to be known as the keys for the index. And that's really how the index is going to be structured and sorted by. Now, if we had a non-clustered index, think of a non-clustered index as our book analogy. It's a completely separate data structure from the book itself. The index sits in the back of the book. It's all by itself, and it's really just a pointer. The index just points to where the data is in the book. Well, that's exactly what an index is in SQL Server. So really, these leaf pages are just pointers to where the data is in the data pages in our heap. All right, so wherever they exist, all over the place, they'll be spread all over the place because they are with heaps. That's the whole point of a non-clustering. It's going to bring some organization to this, and the leaf level of our B tree, which I'll talk about in a second here, just points to where the data sits. File ID, page number, row number, exactly where the data is. So when SQL Server executes a query to find the data, it's going to navigate the B tree to find out where it is and jump right to the data rather than have to read the entire thing. And a B tree, by the way, stands for balanced tree. And really, the root node and all the intermediate nodes, you may have many levels of intermediate nodes depending on how much data is in there. But this is where our keys come into play, because if we were to create an index on an integer column, then what it would do is these intermediate pages would just contain keys. Say this part of the tree contained keys 1 to 5, this part 5 to 10. So really, the root and the intermediate are just a navigational structure to get it to the leaf pages. And in a non-clustered index, the leaf level of the index are just pointers to where the data is in the heap. Now, the other popular index type that's going to affect the actual structure here is going to be the clustered index. And a clustered index is much like a telephone directory, a phone book, in that you're going to look up a phone number by somebody's name. Once you found the name you're looking for, you found the data because it's there with the name. So it's not a separate structure like a non-clustered index. And the real big difference here comes in the leaf. The leaf node is the actual data itself in a clustered index. And now if you build a non-clustered index on top of a table with a clustered index, that non-clustered index, rather than, and by the way, this is called the row identifier here, the leaf node, when it points to where the row exists. But rather than this be a row identifier like it would in a non-clustered index, the non-clustered index would contain the clustering key. So it could, again, find the data using the key rather than find the data where it exists on a specific data page using the row identifier. So some of the important things to take away from the anatomy of an index here in this slide are going to be, if a table has no clustered index on it, it's going to be known as a heap, where it's just going to be a big pile of data pages, and SQL Server will need to scan all of the data pages when a query comes in to find the data that's looking for. Unless there's a non-clustered index on top of a table, and the query comes in that can use the non-clustered index, then it'll know where to look for the data, which will give us huge performance increases. A clustered index on a table, however, will get rid of a heap, and it'll completely organize the data under the hood in the index itself. And that indexes in SQL Server are balanced trees, which are really just a navigation and path system to quickly find the data in an index. SQL Server supports many kinds of indexes. The common ones we'll be working with, and you'll be working with most of the time, are going to be clustered, non-clustered, and covering and filtered. Covering and filtered are just variations of non-clustered indexes, or extensions really of non-clustered indexes. And these can work with all different kinds of data. And again, they're going to be your common go-to indexes most of the time. The other four down here at the bottom are really special indexes that work with specific data types: full text, column store, XML, and spatial. So let's start at the top here with clustered. And a clustered index, as we saw in the previous slide, dictates the physical order of the data in a table. And because of that, you can only have one clustered index per table. So good candidates for a clustered index as far as columns go are going to be those columns that are frequently searched on by range. So anything that does a greater than or less than, greater than equal to, less than or equal to, and even the between operator are going to be a good candidate. Also, columns that contain a large number of distinct values. Also, queries that return large data sets, and queries that return single results. Those are all great candidates for a clustered index. And really, the only things to avoid as far as clustered indexes go, table-wise, are going to be tables that are really small, because your queries will probably end up just doing a table scan anyway, because it'll be faster than navigating the clustered index, so it'll just scan all the data pages. And those tables that have an extremely high number of data modifications, because remember, the data is the index. So anytime a data modification comes in, SQL Server needs to keep that tree balanced and shuffle data pages around and mess with our intermediate nodes in the B tree to make sure that it's balanced. So those are really going to be the only two areas that you want to avoid clustered indexes. We also have non-clustered, and as we saw, the index structure itself is separate from the data. It just points to where the data sits. And because of that, we're not bound to having one non-clustered index per table. We can have many, many, many non-clustered indexes on a table. And non-clustered indexes are great for those queries that return small amounts of data. Another good way to tell where a non-clustered index should go is equality comparisons. So look in your where clauses across your queries. If you see a column that's constantly popping up with an equal sign next to it, those are going to be good columns for non-clustered indexes. And also anything that's joined. All your joined columns are going to be great candidates for non-clustered indexes. Covering indexes is really just an extension of a non-clustered index. What we can do is we can take and build a non-clustered index and then include extra columns into it. And what SQL will do then is it'll take those extra columns and include them at the index level. So if SQL Server were to receive a query and everything that that query wanted was a part of our non-clustered index with the covering part of the index, those extra columns, then it can satisfy the entire query through just the index rather than having to jump through the data pages. So it's a way for us to identify and supercharge specific queries. So we can give them a serious boost in performance by doing what's called covering the query. So it's one of those popular things to do on, maybe your top 5 queries that hit your database is to cover them and create indexes that are specifically for those queries. So again, our top 5 queries, then we can really give a boost to as far as performance goes. Filtered indexes came out in SQL 2008, and they're really neat. Think of it as a way to put a where clause on our index. And it's really a way for us to create a very small B tree on a non-clustered index. Because say we have a table with 1,000,000 rows in it, and we have a query that's constantly hitting one of the columns that maybe has 5% of data in it, and the rest of it's all null. So we can create a filtered index on that column and say where this column is not null. And the B tree will only then be created for the data in that column that isn't null. Now, onto some of our special index types. Full text indexing gives us a way to speed up the searches for specific words in a text column or a character column. So your description columns, your comment columns, things of that nature, we can put a full text index on, and then developers can use full text type queries to do some really neat stuff. You can do anything from just basic, speed up my text searches or word searches against text fields, or you can do inflection or semantic searches where you can do things that, you search for the word drink, you're also going to get drank and drunk and drinking and drankin and drunken and all the different words that sound like drink. So full text is really cool, and it's pretty easy to implement. You can only have one per table, one full text index per table, and it's really going to come around managing your population schedule, because usually there'll be a lot of data that SQL Server has to go through and index specific words. And by the way, the full text index is not a B tree. It uses a special token system to identify relevant words and then index them. So it's really going to come down to managing that population schedule. And it again kind of goes back to if you have a table that doesn't have a lot of updates on it, you could probably get away with populating it in real time. Anytime an update occurs, it'll automatically populate the index. But if you have a table that has an extremely high volume of updates, like comment fields, for instance, then you're probably going to want to put it on a population schedule rather than do it on the fly. The column store index, new in SQL 2012, is meant for data warehousing. You can dramatically speed up your data warehouse queries by using the column store index, and it does not use a B tree structure either. It actually uses a new storage technology that's based on the column itself. We also have XML indexes, which are great for XML data and XML data types. And XML is slow to work through, because it's hierarchy based, it's node based, so you have to traverse the XML structure to pull out the data that you need. So XML inherently is just slow to work with and parse. Well, an XML index will do what's called shred. It'll shred the XML data and store it in a way that it can really speed up searching on it. So you first need to create a primary XML index, and then you create secondary indexes depending on the kind of searching that you do. If you do exact match searching for a specific value in the XML structure, or if you do a path, if you kind of navigate it using XQuery. And there's also property-based searching. So I'll show you when you go over to the Virtual Nugget Lab how you can create a primary and then create a secondary and the type of queries you can use for your secondary XML indexes. But regardless, we have a way here to speed up our XML queries. And we also have spatial indexes, which are good on the geometry and the geography data type. And we can use those data types to really put coordinate-based data. So if we're going to plot out points on a map, or if we're going to draw geometry objects here on a two-dimensional or three-dimensional plane, then a spatial index will be good for speeding up those queries against that spatial data. Moving on to statistics. Statistics are just like they sound. It's information about how the data is distributed within a column. And statistics are actual physical database objects, and I'll show you where they are once we get over to the virtual Nugget Lab. But think about statistics a lot like you would your favorite sports team. So coaches, how they determine who they're going to play is usually based on how players are performing, right? And they analyze how they're performing based on their statistics. So if SQL Server was our coach, then our the query optimizer would be our offensive coordinator. And so together, they'll use statistics. The coach will take the statistics, give them to the query optimizer whenever a query comes in. The query optimizer, our offensive coordinator, will look at all the different plans, all the different plays that they have, and choose the best play, in SQL Server's case, to find the data using the most efficient route. Or if there's many indexes, if there's a clustered index, it'll create a plan that uses the appropriate index to find the data. Thankfully, we do not have a lot to worry about when it comes to managing statistics. By default, auto-create and auto-update statistics, a couple of flags at the database level, are turned on. And we looked at those in a previous nugget. And 99% of the time, that's where you're going to leave them. There'll only be rare circumstances where you'll want to turn statistic updating and creating off and manage them yourself. Now, something we will need to be concerned with, especially if we want to keep our indexes optimized and performing at a great level, is fragmentation. Fragmentation occurs when data is constantly getting pushed into our table. Our indexes are going to split. So page splits will occur, and that's when a page gets full. SQL will need to split the data in the page, move it into another page, and that's partially to keep the B tree balanced, but also just to expand the storage because as data goes in, our tables get bigger. So when that occurs, our data is going to get out of whack. It's going to get out of sync. And so the logical and physical order, logical being the index, physical being the data itself, become disjointed and unsynced. So when that happens, SQL Server has to do a lot more hopping around the B tree to find the data and satisfy the results of a query. So we've got a couple of ways to deal with fragmentation. One of the popular ways to do it is to tweak your fill factor setting. And the fill factor, we looked at it in a previous nugget. We did it at the instance level to make it a default fill factor for the entire database. But you can also do it at the index level. When you create an index, you can specify a fill factor. And again, it's going to come down to knowing your ratio of reads to writes. Because low update tables, you can specify a high fill factor of maybe 100%. Probably a good idea on extremely low update tables, because that's just going to determine how full our data pages can get. So we'll reduce page splitting if SQL Server is filling up our data pages all the way full, but we do not have a lot of writes on the table. On the flip side of that coin, if we have a table that has an extremely high volume of updates, we can turn our fill factor down. SQL Server will not fill the pages up as full, and page splitting will occur less frequently. Now, the best way to deal with fragmentation is going to be to rebuild or reorganize the index. And we'll talk about the pros and cons and the differences between rebuilding and reorganizing, but essentially they both get the logical and physical order back into sync, so SQL Server has less to do to find the data. And what I like to do is figure out the rate of fragmentation on some of the big tables in a database, your busy tables, those ones that become easily fragmented, and then put them on a maintenance plan that rebuilds or reorganizes based on that rate of fragmentation. And I can't tell you how many calls I get over the years from clients and other DBAs and IT staff that says, hey, we've got an application where when people hit the save button in a certain screen, it takes forever, and it just seems like the problem's getting worse over time. And I usually say, as long as the hardware is good and you don't have other outstanding issues with your SQL Server, then it's probably going to be a design issue. It's probably going to be an issue with your indexes, either not having indexes, your queries not hitting your indexes, or if they are hitting your indexes, then they're probably fragmented and you don't have them on a maintenance plan where you reorganize or rebuild them. And usually it comes down to that. It comes down to, sure, the individual who built the indexes, they look good, queries are using the indexes, but there's no maintenance plan, because that's usually a DBA's job to set up a maintenance plan that will rebuild or reorganize the index. And I love walking people through that. I love figuring out with them the rate of fragmentation. I usually say, hey, call me when they become 99% fragmented again. And sure enough, a couple of days later, I'll get a phone call that says, hey, I'm on our busiest table in the database. It becomes fragmented every couple of days, up to 95 to 99%. And that's when I tell them, we need to lower your fill factor, and we need to get a maintenance plan set up that will rebuild or reorganize your index every couple of days. Then it's a great feeling when you get that email with those emoticon smiley faces all over the place a few days later, thanking you for for solving their performance issues. So just keep that one in mind. A lot of times your performance issues from applications into a database are going to become because of lack of an index strategy, or lack of properly designed indexes, or lack of a maintenance plan on your indexes. All right, why don't we head over to the Virtual Nugget Lab, learn how to create all the different flavors of indexes. We'll talk about how to design queries that use indexes. We'll look at query plans to see if indexes are actually being used and how SQL Server creates that path to the data. And then we'll look at how to create a maintenance plan so we can ensure that our indexes stay highly optimized. All right, so we're in the Virtual Nugget Lab. I've pre-launched SQL Server Management Studio. Let's fire it up here. Pre-opened our solution for this series and opened up our project here for this nugget. And we're going to start with how to create indexes. And here's what we're going to do. I've got a connection to our eval instance. We have our Nugget Demo DB database that we're going to be working in for most of this nugget. And we created a table called Sales Archive in a previous nugget. So what we're going to do is we're actually going to blow this table away and recreate it, because we're going to add some more columns. We're going to add a sales status column used for filtered indexes. We're going to create a description column used for full text indexes, transaction info column used for XML indexes. So we'll take a look at all your standard index types: clustered, non-clustered, covering, filtered, some different ways to use them, and then we'll get into some of those specialized indexes as well. So let's highlight all this code. And by the way, this last bit of code here, we're going to add 500,000 rows into that table as well, because that will give us plenty of data to work with to test out our indexes and to see if they're going to help us performance-wise, because we'll run some queries before the index, after the index, to see the kind of performance gains that we get. So let's start with clustered indexes. I'm just going to scroll down a little bit to the Transact SQL code. I'm going to show you how to create the actual clustered index in the interface. But what I really want to show you first is if we were to execute a query right now against this table with no indexes. In fact, you can see this if we expand our sales archive, expand indexes, there's nothing there. Completely unindexed table. What we can do to see how SQL Server retrieves the data is up here we have the include actual execution plan. This will show us the query plan that SQL Server used to find the data. So if we hit execute, we're going to see another tab pop up here when it's done pulling back all the rows. This is going to take a little bit because we're pulling back all 500,000 rows on a table without an index. So if we look at the execution plan, guess what it did? It did a full-blown table scan. And look how long that took. You can see your estimated I/O cost there, 1.7, estimated operator cost, CPU cost. So that was a pretty expensive query there to execute. Oh, and you want to see something really sad? Let's highlight the entire query and hit execute. That's just going to pull out one row of data, and it still had to do a table scan to pull out one row of data. So this is absolutely something that we could use an index on. All right, so let's add a clustered index first here using the interface. So I'm going to right-click on index, choose new index, and clustered index. So you can give it a name. We're going to make this one unique as well. And we're doing this just to get ahead of ourselves, because once we get to full text indexes, you need to have a unique index on the table. So we'll make our clustered index unique, and it is by nature anyway, because if we hit the add button, we're going to add this to our, we're going to make the key for this index the sale ID. And that is unique because it's just our auto number field. So there's 1 all the way up to 500,000 right now in the table. And this is a perfect candidate for a clustered index because it's got a high number of distinct values that's completely distinct. It's an integer data type, which are good to keep your indexes small. And indexes on numeric data fields are, as good as it gets, really. And anything that any queries that are going to hit this table are going to hit the sale ID to probably pull it back based on the sale ID. And again, that's going to be good for a clustered index as well. So this all looks perfect for a clustered index. Let's hit OK. And if we head into options, the only one I want to point out here is a fill factor, which we can leave at 0 for our archive table because it's an archive table. Probably not going to be a lot of inserts. And in fact, archive tables usually you'll load at the end of the week or the end of the month in a bulk load process. And usually when you do bulk loads, you disable or delete the index and then re-add it after the bulk load is done. Always the best thing to do. So there should never really be any writes outside of our bulk loading. So we can leave this at 0, leave those data pages nice and full. And then, by the way, on storage too, let's just put this index on our indexes file group. That's what we made it for. So we're good. So we hit OK, and it's going to create that index based on all that data. There it is. Our B2 structure is in place. Now let's execute this query and see what happens. So if we look at the execution plan, it did a clustered index seek, which is great. It's exactly what we wanted. And look at those I/O and all the estimated costs dropped from 2 point something way down to an astronomically low number. So we can get huge performance boosts in this case. And here's how you do that in Transact SQL. Just to create clustered index, add a unique in there if you want a unique, followed by the name, followed by what table it's going on, and then in parentheses your key columns. And you can separate them by commas if you have more than one column as your index key. Now let's move on to non-clustered indexes. And first what I want to do here is just show you, if we just run a query here, grab sale ID from sales archive where the product ID is greater than 5, this is going to use our clustered index. And you would think it would do a pretty good job at the clustered index, but if you look at it, our I/O costs, again, are pretty high. So we could tweak this even further by adding a non-clustered index on top of the clustered index that target queries that go after product ID in the where clause. And then sale ID, since it's our clustering index key, can be pulled out of the clustered index. So by adding a non-clustered index on our product ID, we should really speed things up. And we also want our fill factor, as we mentioned, at 0 here. So let's flip that back to 0. And you could just wanted to show you here, it doesn't like 0. It needs to be 1 and 100. It's just Management Studio, you can put it at 0, which is 100. So let's turn that to 100, like so. And now let's create that non-clustered index on top of our sales archive table, on top of the product ID column. So there it is. We can refresh our indexes here to take a look at it. There it is, IX underscore product ID. Now let's execute this query and see where it gets us. See if we get any performance boosts there. Now it took an index seek, and we did. Look at those massive performance boosts as far as operator costs. They were, again, with the clustered index all over 2 point something. Now we've dropped it down to probably less than a quarter of what it was before. So that worked, and it used the non-clustered index because it was the fastest route to pull the sale ID based on the product ID. And the sale ID is the key for our clustered index, where the product ID is the key for our non-clustered index. Now let's take a look at another query that's very similar. It uses the product ID in the where clause. The only difference is our select list, we're pulling everything back rather than just the sale ID. So if we execute this, what index do you think it's going to use? You'd say, oh, what about the non-clustered index we just created, right? Well, no, it's going to go back to the clustered index because it needed to get all of that data, and it figured out that it was the fastest route using the clustered index to pull it all rather than the non-clustered index. So this would be a good case to use a covering index to cover our queries. And now, most of the time, hopefully, you work with applications, and whoever your developers, whether they're database or application developers, write these queries, will not do select star and pull everything back all the time, but rather they will choose the column list and they'll pull back only what they need, and hopefully ever only what they need. So select star, is the lazy man's way out of programming. So when you see queries like this come in, and if you see them coming often, you could certainly give them a performance boost by covering the query. And covering the query is really just creating a non-clustered index, adding the include, and then specifying our non-key columns. So again, if our product ID is the key column for a non-clustered index, we can include all the columns that we see in the query, and they'll be stored as part of the index there. So now, if we create this index, and we execute our query, it should use the non-clustered index because all of the results could be satisfied through the index itself. And there it is. And we get a little bit of a performance boost doing that as well. We even shaved a few seconds off of the query when it used the clustered index. Oh, and if you want to do that using Management Studio, let me just refresh our indexes and go into the properties for our covering index. Once you define your key column, just flip over to your included columns tab here and add them the same way. Now let's move on to filtered indexes, and let me run up to the top here just to show you. We added a column called sales status. And when we loaded our 500,000 records, I had a little bit of logic in here that says every 1,000 records, turn that sales status to 1. So what that'll equate to is out of 500,000 records, we have 500 that have a sales status of 1. So this could be something like, we have old outstanding sales that are open in our archive table, and maybe a report is ran at the end of every day to find out what those sales are. And because this is a small subset of data, why would we want SQL Server to scan all of our table just to find the small subset of records, or even scan a big index to do so? So we could really speed this query and that report up quite dramatically by adding a filtered index where the sales status equals 1. So first, let me just run this query without a filtered index. Let's see the kind of performance that we have, because it's going to end up using the clustered index here. As you can see, there it is, our clustered index, to get that data. So it had to traverse quite a bit of data just to pull out all those records. And you can look at the performance, the estimated costs there were around 2.2 and 2.8. So remember those numbers, because you're going to see a dramatic performance increase. In fact, this is really what's neat about the execution plan. I'm glad this popped up. But you can see your missing indexes from your execution plans to see what you should be creating based on the query coming into it. And this is telling us that we could do an include. We could create an index on the sales status with an include on the sale ID. Well, I'll take you even one step further here and create a filtered index on top of that sales status where it equals 1. So let's do that. And now let's execute our query to see our performance gain. See if we gain anything from that 2.2, 2.7 range. And look at that, 0.003 to 0.003. So that was a pretty significant performance gain there by using filtered indexes. And I've got to tell you, I'm actually a pretty big fan of filtered indexes. Since they've came out, they've helped me in a few areas, helped me speed up things like reports and some queries from some applications that do select a small subset of data often. So keep these in mind. And as far as maintenance goes, they're easy to maintain because they're generally small, since they only target a small subset of data. So keep filtered indexes in your mind. They certainly have their place in the indexing world. Now let's take a look at XML data. So what we're going to do here is I've got some queries that we're going to update the transaction info column. And if you remember here, if we scroll up top, I created a transaction info column and I marked it as the XML data type. So now we just need some XML data to work with. And we're going to say we've got a column called transaction info, which just contains information about, we probably should have called it shipping info, but we'll just call it transaction info for now. But it has all the shipping information: when it's shipped, the arrival date, tracking number, and the package dimensions. So let's highlight these 3 update statements and execute them. So it'll give us some XML data to work with here. And now we can create our primary XML index. And again, the first index you need to create is the primary XML index, because that is so SQL Server will take our hierarchy of XML and shred it, put it into a format that's easier for it to traverse to do searching on it. So if we highlight this query and hit execute, it's going to yell at us and say that we need to have a clustered primary key in order to create a primary XML index. So we have a clustered index, but it's not a clustered primary key. So let's actually delete this. And I'll show you an easy way to make that would be to go into your table, right click, head into design, and now let's just hit the sale ID and hit the primary key button. And once we hit save, it'll give us, because we already deleted our clustered index, it should give us a new clustered index. Now if we were to just do that while already having clustered index, it would create the key as a non-clustered index, in which case you still wouldn't be able to do so. So let's refresh this, and you can see there it is. It created a clustered primary key index. So now we can try to highlight our code here and hit execute, and we're good to go. So now we can create secondary XML indexes, and this is really going to depend the type of XML index you create on the type of queries that are hitting the XML data in the database. For instance, if you have a lot of queries that use the .query method, which is a way that you can traverse the nodes and pull out the actual XML nodes themselves, these are known as path queries. For instance, if we just execute this, you can see it's going to pull out the tracking number with the XML data itself. So these are known as XPath queries because they're not pulling out specific values. They're pulling out the entire node. And if we were to turn this into something like package dimensions, it would pull out everything within package dimensions. And just to click on that, just to show you everything. See that? Now, the other side of that is value query. So here's a value query, and this is because it's actually traversing to a specific place. It's looking for a specific value in the XML data, and it's pulling out only the data, not the nodes. So for instance, if we wanted to see the tracking number for the sale ID where it equals 100,000 in our XML data, there it is. See, it's actually giving us the data itself. And there is one more called property, which is good for working with XML properties like attributes. If you had some queries that were pulling out specific attributes, then you could use a for property. So figure out what kind of XML queries, or if you have a specific XML query that you want to create an index on, figure out which kind it is. Is it path, value, or property? And then create an index on top of it. And it's just like creating any other index. You just have to specify that you're using and what primary XML index you're basing this on. And then for path, value, or property. So if we do this and hit execute, we now have a secondary XML index for path on top of our sales archive transaction info column, and now that will dramatically speed up our path queries. So those are XML indexes. Remember, it just comes down to creating a primary and then figuring out what kind of secondary index you need to speed up those queries against XML data. Now let's also take a look at full text indexes, and we're going to do the same thing we did with XML here. We need some data to work with. So we're going to update our description column to have some textual data. And not just your typical text data, but actual, full-blown sentences that could be good to search by using full text queries. So let's update it, and here we're going to have 5 queries this time to get us some data in there to work with for a full text index. And now let's execute this full text query without a full text index. And look at that, it doesn't work. And that's because this contains statement here is actually specific to full text. You need to have a full text index in place to even work with this function. And without a full text index, you'll probably see queries like this, where they'll do where description like, and then we'll use the wildcard characters bike. All right, so now we've got kind of both worlds here, and we can take a look at the execution plan. You can see that used a clustered index, and it took some time to do. So let's put a full text index on here and see if we can speed this up. And obviously, with 5 records full of data, we're not going to see huge differences. But imagine huge tables with huge descriptions or comment fields. Something like this would take absolutely forever with just your standard wildcard characters than the like operator. So that definitely good candidates for common fields, description, things of that nature. So let's create a full text index on our sales archive table. We can just right click on it, head into full text index, and choose define full text index. This will take us through a wizard. We'll choose next here. The first screen is just having us select our unique index. You need to have a unique index on a table in order to create a full text index. And if you have multiple ones, you can choose which one you want to use. We only have one. Even our previous clustered index that we deleted that was not a primary key, we made unique, so we would have been able to choose that. But our XML indexes required our primary key clustered index, so we created it. All right, so let's choose next here. This second screen here, just what columns we want a full text index. Pretty straightforward. Let's choose description. This type column is really interesting. If you are full text indexing a binary column that stores, say, Word documents or Excel spreadsheets, you can choose the type here, .xls or .doc, and then SQL Server will be able to full text and work with the data stored within them. So pretty handy feature there. So let's hit next here. And now change tracking. How do we want change tracking to occur? Do we want SQL Server to automatically update the index when changes occur? Do we want to do it manually? Which is a good idea if you have an absolutely huge table where a lot of updates on comment fields are happening. It'd be a good idea here to do manual. That way you can repopulate the index on an off schedule. Or you can choose to not track changes at all, but still start a full population when the index is created. Let's do manually and choose next. And this next screen is catalogs are really just containers. They're containers for full text indexes. So if you have a lot of full text indexes across many tables in your database, we can create a container, a catalog, and store all of our full text indexes in one catalog. And then we can create a maintenance plan that populates them based on a catalog rather than a table, which you'll see on the next screen here. So let's just call this our Nugget Demo DB catalog. We'll set this as the default catalog. Your accent sensitivity is just how characters with accents on them are compared. And then we can choose our file group for the index. Let's just choose this as our indexes file group. And then you can also specify a stop list, so you can, you won't index those filler words, those is, that, and, so on and so forth. So the system supplied one has all those words. You can also turn this off, and you can create your own user supplied stop list as well. So let's hit next. And here is our population schedule. So you can do it based on a table, or if you have many full text indexes tied to a catalog, then you can create a catalog schedule. Let's just choose next. Everything looks good. Now we can hit finish, and we're good. So our full text index is created, and if we right click and head into full text index again, you can see that we've got some options. We can disable it, we can delete it, we can stop our population. It's currently populating right now, and you can also control what kind of change methodology you want. And then you also have your properties here. If you click on property, you can go in. Here's all the general properties. Here's the columns we chose, which is just our description one. And then you can also manage your schedules there. So not much to creating a full text index. Pretty straightforward, but that'll also give us the ability now to run full text indexing type statements like we have here. So if we hit execute, there it is. And you can see here that it used our full text index, which is a full text match, as well as our clustered index to pull the data out. And this is a lot faster. In fact, if we run both of these, this is a really cool feature. Both of these, we can hit an execution plan and see that between both of these, this first one cost 100% of the batch. This second one was so fast it didn't cost anything, 0%. So usually when you run queries together, you'll see, you can see which one performs better. And this one, you can tell, I mean, it costs 0% relative to this one costing 100%. So it was extremely fast doing our full text search, our full text query based rather than our regular query here. Now let me show you one more kind of index here, the column store index. So this is a brand new index in SQL 2012 meant for those data warehousing columns. And I also downloaded and attached here the AdventureWorks Data Warehouse 2012 database. So I'm not going to get deep into data warehousing. There's a whole other exam and series waiting for you there. But I will show you here that we have dimension tables and fact tables. And your fact tables usually contain all the detail data, and then you tie to them your dimension tables to get different views of the detailed data. So if we head into the properties, just to show you here, this fact product inventory is the biggest table in here, and it contains 750,000 rows, so quite a bit of data to work with. And if we run this query here, which is based on the fact product inventory table and then ties in products and dates based on their keys, and then we group in order by so we can get a good view of this data. And let's just execute this. Oh, you know what? We need to switch our database here. There we go. And now if we execute it, and you know what? Because we're on a different connection now, we have to include the execution plan. So let's take a look at that execution plan too here. Re-execute it. You can see that it took about 3 seconds to pull in 62,000 rows of data. Not too bad. But if we scroll over here, you can see we're doing a clustered index scan on the dimension. And if we scroll over to the right here, another clustered index scan on the dimension. And down at the bottom, another clustered index scan. So it's doing 3 clustered index scans across all 3 of our tables. So if we wanted to speed this up, we could create a column store index that really covers this query. So we'll create a column store index on our table and then specify what columns we want to create the index on. And we're going to create it on the product key, the date key, and then our summarized fields. And that's going to be really the best way to create these indexes are on your join columns and then on the columns that you're going to summarize. All the 3 parts that are really going to take the longest to do as far as this query goes. So let's create this non-clustered column store index on those columns. And that'll take a little bit to create on those 775,000 rows. There it is. And now if we execute this, should take a lot faster. Look at that, all the way down to a second. If we look at the execution plan, it's still going to do a clustered index on the date, clustered index there on that. But at the end here, our fact table, it's going to do a column store index scan. So that really pushed it down quite a bit as far as performance goes. And imagine this on a data warehouse of millions, if not billions of rows, then we would have really shaved a lot of time off this. So this is a really nice brand new index type that you can use for data warehousing. So if you're going to get into data warehousing, keep this column store index in mind. All right, let's move on to maintaining indexes. And we're going to start here with fragmentation. So let's get back into, actually we're going to do this in the AdventureWorks 2012 database, but just to show you a couple of things here in our NuGet-DemoDB, I refreshed our indexes. And to deal with fragmentation, if you want to do it at the index by index level, you can just go into your indexes in the interface, right click on an index, go into properties, and head down to fragmentation. So this will give you some good information on the page fullness of the index, the total fragmentation of the index, and then some other information about the index. So that's one way to do it. Another way to do it, and this one we're going to use the AdventureWorks database for because we've got some fragmented indexes in here to look at, is to run this DMV. This DMV will give us a view of all the fragmentation across all the indexes in the database. And here's the DMV here, DM_DB index physical stats. You can join this to the indexes to pull out what schema and what table it's on. And if we just highlight this and hit execute, we will get all the tables, all the indexes in the AdventureWorks database. So this is just telling us the schema and the actual name of the table. If you want to see the index name, you can scroll over to the right here, and you'll also get the index name under the name column. But what you're looking for here is the fragmentation. Here it is, average fragmentation in percent. So you can see we have some pretty fragmented indexes going on in this database, especially this one. And the general rule here is anything under 10%, don't worry about it. Anything in between 10 and 40% is light to moderate fragmentation, and you can reorganize that index. Anything above 40%, you'll want to rebuild the index, which will actually physically drop it and rebuild it. All right, so that's one way to find out, to view your fragmentation. So when you actually want to do something about it, we can run the alter index all, or you can also put a specific index on, specify the table that the index is on, or all, will do all indexes, and then reorganize or rebuild. So reorganize just reorganizes and resyncs the leaf nodes up with the underlying data pages. And it also does not update statistics. So this is one of those things as well. If you have a huge table with a lot of indexes on it, that may take a while. Reorganize takes a lot less time. Where rebuilding is physically dropping and rebuilding the index, but you get a lot more out of it because it reorganizes the entire index and updates statistics. And you can also do this in the interface. If you want to rebuild a specific index, just right-click on it. There's rebuild and reorganize. Or if you want to do them all, just right-click on the indexes node. Here's rebuild all and reorganize all. And speaking of statistics, if you are in the situation where you need to manually update them, here's how you can do it. You can update statistics followed by the name of the table if you want to update all the statistics on a table. And you can specify with full scan, we'll scan the entire table, all the data in the column, to generate the distribution and to generate the statistics. You can also do it with sample if you want to sample a certain percentage of the table. And if you want to do them manually, you have your statistics node down here. You can just expand them. Here are the statistics. These are for columns. These are for indexes. And if you want to look at a specific statistic, you can right-click on it, go to properties. You can see the column that it's based on. And if you want to update them right now on the fly, you can just tick that box and choose OK, and then it'll update them. You can also get some details, which will actually show you the histogram here for the stats themselves. Now, something else extremely useful we can do here is put SQL Server to work for us to identify what indexes we should have and what indexes we have that aren't really doing anything but wasting resources, as SQL Server is still maintaining them and will be probably maintaining them through a maintenance plan as well, even though they're not being used. So if we just highlight here our missing indexes DMV, and this just runs through the 3 missing index DMVs, ties them together, and you can get some pretty good information in here. But again, it's not the greatest information to digest. It'll take a little bit of time to figure out what all these columns mean. But at the end is where all the real good columns are. It shows us what it's suggesting as far as the equality columns, inequality columns, and then our included columns. So this one, we should create an index in our sales table in the Nugget Demo DB. We should add sale amount as one of the key columns, and then we should add all these as included columns. So that's a good suggestion based on the queries that I've been hitting our sales table. But let me tell you, for missing indexes, I think one of the greatest tools out there is the Database Engine Tuning Advisor that comes here with SQL Server. If you go to your program files directory inside of 2012, down in Performance Tools, here's the Engine Tuning Advisor. I'm not going to go through it, but I will tell you, it's really easy to use. What you need to do is use SQL Server Profiler to create a trace, or to create what we call a workload. And then you can send that workload to the Tuning Advisor. It'll analyze all the queries that have hit the database over time, and it'll give you some great recommendations. It'll even write the Transact SQL for you, so you can just simply copy and paste it to create your indexes. So if you really want to optimize or tune your index strategy, or even if you don't even have an index strategy set up and you want one, then I would certainly advise setting up a trace for an afternoon, or maybe during the busy time, or maybe even an entire day, just so you can get a nice big workload of what happens in your database in a day. Send that to the Tuning Advisor and see what it comes up with as far as an indexing strategy. Now, if you want something really quick, though, just run these DMVs, especially if SQL Server hasn't been restarted in a while. Then these DMVs will be loaded with good statistical information that SQL can use to make those missing index decisions as well. As far as unused indexes go, we have the index usage statistics here, DMV. This one, if you run it, this is not giving us all of our unused indexes, but it's giving us how all of the indexes in the current database, and we did this on the AdventureWorks database, how they're being used. So if you see a lot of zeros on user seeks and user scans, then you'll know that the indexes aren't really being used. The only thing to be aware of here are primary keys. Like I bet this one's a primary key here. It's got 0 in both. I wouldn't worry too much about primary keys coming up with zeros because they're more constraints rather than performance enhancers for queries. They're there to enforce uniqueness inside of a table. So don't worry about seeing zeros for primary keys, but if you see them for non-clustered indexes, then I would be, I would think twice about using that, maybe removing, disabling, or altering it so it is used. Some other tools that we can use for maintaining indexes are going to be reports, and we've got some awesome reports. One of them is the physical index report that'll let us get some information about fragmentation. It'll even recommend if we should rebuild or reorganize it. And then the other one is seeing how indexes are being used and if they're being used. So let me show you first the one that we can use for fragmentation. So if we right click on the database, head down to reports, standard reports, we have index physical stats. So if we open this up, here's all the indexes in our Nugget Demo DB database. And our sales archive table, which we just created all these, so we shouldn't have any fragmentation issues, and we don't. But our sales table we've been using for quite a while in this series, taking a lot of data in and out of it. So you can see we have the operation recommended is rebuild. So I'm going to guess that the fragmentation is pretty high if it's recommending a rebuild over a reorganize. And if you expand your partitions, you can get that information. Look at that, we're 87% fragmented for our product ID index on the sales table. So this is definitely one we would need to rebuild. But overall, this is just a great report, easy to digest, easy to look at and understand, and great for figuring out your fragmentation as it's a centralized piece for all the indexes in the database. And the other report I wanted to show you was the index usage statistics report. So if we head down to reports at the database level again here and choose the index usage statistics report, this is a great one for finding out what indexes are being used and if they're being used and how they're being used. Because we can see here in the usage statistics, here are all the non-clustered and primary key index we created. And this shows us seeks versus scans versus updates on the index and gives us the time that they were last used. So a good one for troubleshooting. Another one is the operational statistics. And this will give us a lot of the same data. But if you have a bunch of indexes in here, you can see how often they're being hit. And if you have an index that you created that isn't in this list, then you know it's not being hit at all. So a couple of great reports there for working with indexes. So the last thing I want to show you is how to set up a maintenance plan to automate a lot of your index management. So let's just collapse our Nugget Demo DB and head down to the management node here and right click on maintenance plans and go into maintenance plan wizard. So let's skip the first screen. This one, let's just call this index maint. And then if you have multiple tasks, say for instance you want to rebuild some of your indexes and you want to reorganize other indexes, you could put them on separate tasks so they run on separate schedules. We will keep them all in the same schedule. We'll just make sure they run sequentially, and then we'll hit next. So this is just what server we want to target here. Since we have master and target SQL Server agents set up, we're just going to target our local server. We'll hit next. Then it comes time to choose what tasks we want to do. So we could say we want to reorganize some of our indexes, we want to rebuild other indexes, and you can even update statistics on here. Now, obviously, if you're rebuilding, then you won't need to update if you're only rebuilding, but the ones that you reorganize, you may want to update your statistics on. So everything looks good there. Let's hit next. Now is the order they want to run in. We could say reorganize, then rebuild, then update, or we could even do this, reorganize, then update statistics, then rebuild, since that's going to be the longest one. So let's do that. Let's hit next. So the first one is our reorganize task. Really not a lot to do here with reorganization. Just choose your database, hit OK, then choose your table or view, or if you want to do all tables and views, you can choose that one. If you want to do specific tables, we can just hit table, drop this down. Let's say our reorganize we can do on our employees table because there's not going to be a lot of employees going into that table on a daily basis. So that's probably one where the fragmentation rate will be very low. So good candidate here for reorganizing. Once we hit next, here's our update statistics task. And let's just do the same thing here. Let's just choose Nugget Demo DB, drop this down, choose table, drop this down, and choose our employees table. So this will run based on the reorganize there. And then we could say the exact options that we saw in Transact SQL. All existing statistics, you can do column or index only, and then you can do a full scan or you can sample the scan. So everything looks good there. We'll hit next. And finally, our rebuild index task. Let's drop this down, also choose Nugget Demo DB. Drop down tables, and let's choose our sales archive table, which are all the indexes that we just created. So this will be one that we could say we wanted to rebuild, or even, it'd probably be a good idea to do sales too, since it's got some fragmented indexes in there. So we'll hit OK. We can override our fill factor here. Default to choose the default fill factor at the instance level, or we can change the free space here, change the fill factor to a specific setting, and then some advanced options. An interesting one here, you can keep the index online while reindexing, and if for whatever reason the index doesn't support online indexes, you can choose not to rebuild or take it offline to do the rebuild. So that's good. The next thing we do is just choose if we want to write the report to a text file or if we want to email the report every time the maintenance plan kicks off. We have a summary. Finally, we hit finish, and there it is. Our maintenance plan is complete. There it is. So if you wanted to alter any of the schedules, you could go into SQL Agent, find the job, and alter the schedule. Otherwise, that's about it here for maintaining indexes. So in the CBT Nugget, we got familiar with implementing and maintaining indexes. We started off with an overview of indexes, got familiar with the anatomy of an index, what an index really is underneath the hood, and we got familiar with the two real standard types of indexes, clustered and non-clustered indexes, and how they differ under the hood. Then we got familiar with all the different index types in SQL Server, got familiar with statistics, talked about fragmentation, and just generally talked about how SQL Server uses indexes to hunt down data. Then we jumped into the virtual Nugget Lab and got familiar with how to create indexes. We also saw how to write queries that use those indexes, and we got familiar with a very powerful tool, which was execution plans, and how to view an execution plan, which will give you a number of good indicators if queries are using our indexes, and even if they are using them, the kind of performance gains we get out of them. So that's a wonderful tool. I'm sure you'll be using it whenever you troubleshoot or design your index strategy. Then we got familiar with how to maintain indexes. We talked about and saw how to deal with fragmentation, how to find out if an index is fragmented, and then if you should rebuild or reorganize it based on the level of fragmentation. And at the end, we saw how we could identify missing, unused indexes and how to create a maintenance plan to automate defragmenting your indexes. I hope this has been informative for you, and I thank you for viewing.